Hello, everyone. This is Ben Goertzel, CEO of SingularityNET, the blockchain-based AI platform. And I want to talk to you today about some of the interesting things we're doing with SingularityNET so far to bring AI onto the blockchain and use this to rapidly move toward higher and higher levels of applied AI and general intelligence, but with underlying decentralized control. And then, as well as what we're doing today, I want to go through some of our future plans, near future, and things that are a little further off. And what's interesting to me about talking about the future of SingularityNet in a Cardano context is a lot of the really interesting things we need to do to bring SingularityNet from where it is now to where it really needs to be to serve as the infrastructure of the applied AI and the emerging artificial general intelligence of the future. A lot of these things we need to do to move SingularityNet forward, really, they have to do with the intersection of functional programming and allied forms of formal logic and blockchain and AI. And of course, what's fascinated me about Cardano from when I first heard of it is the often quite subtle use of functional programming and associated math in the blockchain context. And I think in SingularityNet so far we haven't made a lot of use of functional programming constructs, but there's some very specific things we need to do to move SingularityNet forward that would make very heavy use of this sort of approach. So it's quite interesting to think about. So I'm gonna talk a bit about what the vision of SingularityNet is, what the actual code and architecture of SingularityNet is. I'm going to dig a bit into the weeds here, sort of getting the feeling that there's some fairly technical folks in this audience. I'll tell a bit about what we're doing with AI and specifically artificial general intelligence building on top of SingularityNet as the sort of part of the underlying platform. And then at the end, sort of the punchline and the most interesting part, these are things I haven't actually talked about publicly much before. I want to go through some of the more advanced things we want to add to SingularityNet in the next phases of development and how those will rely on a sort of robust, secure, functional programming infrastructure. So SingularityNet, I'll tell a little bit about the high-level vision before jumping into the technical side. So I'm in the original vision of SingularityNet, which we're still pursuing, is that this is basically what the AI pioneer Marvin Minsky called a society of minds, a society of AI minds and a society of human minds interacting with the AI minds. And you want to have a network of AI agents, each of which has its own intelligence, processing data, giving results, doing some thinking. There's no central controller to this whole network of AI agents, but it operates in a participatory and self-organizing way. The individual AI agents have some intelligence on their own, but through their collective interactions, they can manifest some emergent intelligence, wherein the intelligence of the whole can exceed the sum of the intelligences of the parts. And there's a lot of aspects to building a whole decentralized AI ecosystem of this nature. I mean, it's a software engineering task, but it's not purely a software engineering test, right? I mean, it's also a social network engineering task. I mean, you need AI developers, application developers, and end users, and you need a whole ecosystem of people working on different parts of this, and we're doing all this in SingularityNet right now. I mean, the underlying architectures you need are quite complicated, and blockchain is part of the lower layer. Then on top of the blockchain, you have a whole platform architecture. Then you have data containers and AI algorithms living on top of that architecture. We have a token to incentivize contributions, and then applications built on top of all that. So there's many parts in the stack that one has to build to do this sort of thing. And we certainly haven't built all of them yet, but we're working on it bit by bit, and we built a number of the pieces. And yeah, this slide summarizes the sort of multi-agent cooperative aspect to the vision. So I mean, if, for example, if you have an AI agent that does document summarization, right, then that AI agent, it lives in a Docker container somewhere. It communicates peer-to-peer with other agents in the network, and someone can send it a bunch of documents to summarize through some payment channels and smart contracts. They can agree on payment. But then suppose that document summarizer encounters some videos in the document or some voice in the document it doesn't know how to handle. Well, it could outsource video summarization to another AI agent living in the network. And that sort of thing is a very simple example of interfacing among AI agents. I mean, a subtler example would be an AI trying to reason about physics that outsources work to an AI that can do math theorem proving, or to an AI that can recognize patterns in data tables and so forth. So there's a lot of different ways multiple AIs could cooperate together to solve problems, and we don't want to prefigure all of them in the design of our network. We want to build an environment where others can create AIs that interact with and reinforce each other. We also are trying to build the infrastructure out in a lot of different directions. So there's a spin-off project called NewNet, which is basically focused on taking the AI marketplace that we build on SingularityNET platform to the level of hardware resources, so that the AI can run on the phone, it can run on an embedded device, it can run on various servers, it can run in spare processing power on your laptop. So then the various AIs in this society of minds can use the token economy to marshal up the processing power they need to do what they're doing. And I mean, in the end, NewNet, SingularityNet, and the AI tools I'm going to tell you about a little later, these are part of a much broader decentralized computing ecosystem, which, I mean, Cardano is building huge parts of, SingularityNet is building significant parts of. And, I've aggregated together with Tufi Saliba and Smane Giacomelli, we've aggregated together 55 maybe, decentralized AI-oriented projects together into an industry group called Decentralized AI Alliance. And I mean, as one example, Ocean Protocol has a blockchain-based way to handle big data to feed into machine learning algorithms. Shivam has a decentralized blockchain-based approach specifically to genomics and proteomics data management. So really what we need is a decentralized network of decentralized networks, spreading out horizontally across different verticals and aspects of computing, and also arranged vertically from infrastructure up to applications. And it's a huge amount to build. I mean, what we're up against are an industry full of many trillion-dollar companies building centralized technology infrastructure. But I mean, the computer science is there to support this, and the passionate community is there to support this. So it's been a very interesting quest and continues to be. I'm going to tell you a little now about the SingularityNET infrastructure and more of the particulars of how it's deployed. And this gets a little bit nitty gritty. I mean, I'm not going to walk you through the code or something, but I want to tell you about the software architecture underlying SingularityNET. And I don't actually dig down to this level in talks all that often, but of course it's quite interesting to do so, because I mean, in the end, the details of the smart contracts and the software architecture and so forth, I mean, this is what makes it all happen, right? The vision is worth nothing if it's not cashed out in functioning code. So from the point of view of an AI developer who's trying to put their AI in SingularityNET, it's kind of easy. I mean, if you have an AI process that operates according to a certain API that takes certain inputs and gives certain outputs, I mean, then what you do, you put your AI with its APIs in a Docker container or LXC container, say, and then you put SingularityNet proxy in that container, and then you're basically done. I mean, of course, you need to have a crypto wallet if you want to store or cash out tokens that you obtain. But we tried to make it very, very, very simple. Everything's wrapped up in that one proxy that you drop into the container along with your AI agent. Now, behind the scenes, of course, there's a lot of other things going on, as you see in the diagram. I mean, we're using IPFS for decentralized storage. There's command line interface for interfacing, and then various web interfaces like a publisher and a marketplace that I'll go over in this talk. There's actually a number of different agent registries on the network. We have one registry that we manage at SingularityNet Foundation, the organization behind SingularityNet, but there can be other registries that overlap with that, because it's a decentralized network. It doesn't rely on the centralized registry. Then there's smart contracts dealing with multi-party escrow that deal with payment for services, and we have some ability to allow payment in fiat as well as crypto, which I'll go over shortly. So I mean, there's a bunch of components here. We've built this on Ethereum blockchain so far, but as I will go over, I mean, we've made the architecture as blockchain agnostic as possible, so that if we want to make SingularityNet multi-chain or even port wholesale to some other chain, I mean, there's not a huge amount of code to be rewritten, and I'll explain in a little bit what would need to be done if that were the course we were going to take. So the registry, to talk about briefly, I mean, we have our own registry of AI agents in the SingularityNet network, but you know that the registry is just its own entity that feeds off the network. The network itself doesn't require any centralized registry, and that there's a sort of interesting give and take here, because SingularityNet Foundation offers an AI marketplace with a whole bunch of AI services on it, and to put AI services on our marketplace, we need to do some vetting of what the agents are and who you are to avoid us being sued if someone does something illegal in the pertinent jurisdictions in their AI agent. On the other hand, the protocol is totally decentralized, and you know, for all we know or care, I mean, some Iranian AI guy can make an AI agent that cooperates with some other North Korean AI guy, and that's decentralized protocol, just like internet is decentralized protocol, right? And I mean, people can do whatever they wish with the underlying network, as with Linux or the internet, and I think that's how the underlying infrastructure of artificial intelligence really should be. On the other hand, from the standpoint of presenting a curated collection of AI services on SingularityNet's website and marketplace, then we need to be a little more conservative about our own legal compliance, and this allows us to be a little more polished in how we present those curated tools that we aggregate on our marketplace. And the registry gathers together those AIs that are like basically vetted and listed by the SingularityNet project. And the smart contracts are all over in the infrastructure here. I implemented in Solidity on the Ethereum at this point. I mean, probably the most complicated smart contracts in the now are for multi-party escrow, which I mean deal with the case where one agent needs to pay another agent for some services, and then you have some support functions, and you can have, say, one guy who's paying, one guy who's receiving, another guy whose job is to validate that the services were actually provided by the recipient before they actually received the money. So this was fairly complicated, involving setting up a number of payment channels, but this has been in place for some time now, and much of the complexity in designing this part of the system has really been in working around some of the practical operational shortcomings of Ethereum blockchain. Because I mean, as most people listening to this know, Ethereum is at this point, and it's under rapid development by many brilliant people, but at this point, Ethereum is still, it's expensive and it's slow. So I mean, the cost of the transaction for microtransactions, the cost can be ridiculously high. It's better to bundle up transactions and do them just once to keep the cost per bit lower. Time per transaction on Ethereum can never super fast, can be okay fast, or can be ridiculously slow, right? So I mean, what we do on SingularityNET now, I mean, once two agents agree there's going to be a payment transaction, they set up several channels, and then everything happens along those channels. And what gets recorded in the blockchain ultimately is just the final settlement on chain. And we really take the same approach to everything in SingularityNET. I mean, data isn't on chain, AI operations aren't on chain, and some of this stuff really never ever needs to be on chain. Some of it sort of should be on chain, but isn't in our current design because Ethereum is too slow, and in future redesigns, maybe some of those additional things will end up going on chain. So I mean, there's nothing astoundingly groundbreaking in how the multi-party Haskell contract works, but like any moderately complex smart contract, it took a while to work out. And I mean, you have authentication, you have interaction with the different wallets and signatures and so forth, and that's all totally in the background and in the plumbing from the standpoint of the end user, of course. And I'm just mentioning it here because this is a blockchain audience. Now the daemon is the main part of the software architecture. I mean, that's the main object that deals with the Ethereum blockchain and SingularityNET architecture. So if I make an AI that does image classification or reasoning or natural language translation or theorem proving, that writes news articles, whatever my AI agent does, I put that agent in a container, then I drop the SingularityNET daemon in there, and that's sidecar proxy design pattern in software engineering lingo. So the daemon interacts with all the smart contracts. It monitors the payment states and looks at the wallets to ensure funds are there, make sure the payment channel is there, takes care of the logging and configuration. And I mean, this is what interacts with the multi-party escrow and also with the IPFS and so forth. And I mean, all this is stuff that will be trivial to do in a centralized system where everything was more mature and has been a bit of pain and suffering to get it all to work really effectively, reliably, and scalably on Ethereum. I mean, one of the challenges in this design was to make sure that you have a completely stateless client. Like the client only needs to know its Ethereum identity, and that's it. Everything else that it needs to know, it can get, from the multi-party escrow contract or from the blockchain. And you can use a gRPC method in the daemon to get the current state of the channel. So everything is there. It's in the channels, in the blockchain, and in the smart contract, leaving the client completely stateless and simple, storing only its ID, which is really, really robust and lets you build a variety of different clients. Now, the way, as a developer, the way I would normally interact with this whole combination of components and smart contracts is using a command line interface. So I mean, you can do everything through the command line. You can create organizations, members, services. You can claim funds. You can pay. You can set up a relationship with a new customer, and you can rate the reputation of another agent on the network. You can determine whether using the main net or a local private chain or a test net or something. It's all on the command line interface, which is simple for testing and debugging and so forth. I mean, this diagram gives an example of the workflow for using the command line interface to claim funds. So I mean, the command line interface, it talks to the the daemon, which has initiated the claim, then it goes through to the multi-party escrow contract, and then it may talk to the command line interface that the other guy is using. So you can do everything with the command line interface on either end, and interact with all the smart contracts in the network. And that's certainly how we tested everything. Now, of course, that's not how everyone really wants to operate. So the SDK is quite powerful. We're dealing with Java, Python, and JavaScript, Node.js right now. I mean, actually, our most powerful AI system, OpenCog, that I'll talk about in a few minutes, is actually a C++ based system, but it has a Python wrapper, which it uses to interface here. So the SDK is fairly mature by now and makes it pretty easy if you have a website or a software application or whatever to tie in with SingularityNET platform on the back end without going through the command line interface. And the SDK also supports flexible payment strategies. So, I mean, we have a default payment strategy object, but I mean, you can deal with subscription payments, and you can deal with different currencies and conversion at different rates and so on. So you can create payment strategy objects that let you greatly customize how the system is being used within your product. So there's obviously, that's just one example. There's an awful lot of other things that you can do. From the end user standpoint, you can deal with as much of that as you want. You can go super low level on the command line. You can use the APIs of the SDK, or you can use just a few SDK calls. And if you have an AI agent you're wrapping in the container and wants to put in the marketplace, if you're a reasonably competent developer, you can get up and running with your AI agent on the marketplace in like an hour or something. I mean, if you already have software that's architected to be accessible by API, basically you have to tell the SDK what the relevant APIs are for receiving requests and data and giving results, and tell it what is your Ethereum address, and then you're done. There's not a heck of a lot to do to leverage all this complexity behind the scenes. And then your AI can get up there. It's on the SingularityNET generally. So anyone who puts a peer-to-peer request in the network, that request goes peer-to-peer, link by link through the network, and anyone who wants your agent can just find it that way. So, I mean, if you have an AI agent that summarizes documents, anyone can put a peer-to-peer request into the network saying, hey, I want an AI that will summarize English documents. And then the peer-to-peer request will go through. You'll get a list of the agents that have said they can fulfill that particular API call type of summarizing text documents. And then you can negotiate price with them. And if you come to a positive conclusion, you can carry out a transaction where you give them data, they give you results, and they pay you in the AGI token, which is a native payment token of the platform. But the peer-to-peer method underneath is leveraged in a simplified way by our marketplace dApp, which is a dApp running on the SingularityNET network, and that lets you go to our website, look at a little card for each AI that's been curated and approved and put on there. And then you can use a simplified web interface to set up your connection with these AI agents. And I mean, as simply like a web-based AI marketplace with APIs, it's not really that different looking than, say, Rapid API or some other API marketplace. The thing is, here we have this whole decentralized blockchain-based tooling under the hood, which means that the bottom line is, like, if that marketplace were shut down by the cops or vaporized or something, like the decentralized protocol is still there, and that just doesn't have to be the be-all, end-all marketplace either. We've put it now as a showcase and a convenient way to get services out to users, but one could make a different AI marketplace which had overlapping or different AI agents on it, acting on the same underlying decentralized network. So really, well, we've made a nice AI marketplace on SingularityNET website. The underlying SingularityNET decentralized protocol, it's more of a meta marketplace, really, that anyone could use to put different marketplaces on it. Now, so there's it's interesting, the tension and overlap between these two aspects, right? You've got this underlying decentralized network, and then, which is not the easiest thing on the planet to use, and we've tried to make it as easy as possible. Then we have curated and simplified resources available through SingularityNET website, which are dApps running on top of this underlying SingularityNET network, are the easiest way to get started now, but they don't exhaust the long-term potential of the underlying decentralized protocol. So, I mean, one of the things we've done on our curated marketplace is we've integrated with PayPal, which obviously is not that decentralized, but I mean, it lets anyone with a PayPal wallet buy some AI services. And we're currently working on extending the fiat to crypto conversion using some other payment processors, so that within a few months from now, anyone should be able to pay for AI services by wire transfer, PayPal, credit card, and then AI providers should be able to get paid into their bank account if they want to, as well as PayPal wallet and so forth. So, I mean, the crypto payment is key to how the system works. There's an AGI token, currently an ERC20 token, that mediates all the payment. On the other hand, if we're going to grow this as big as we want to rival and ultimately obsolete the Googles and Amazons and Alibabas of the world in the offering of AI services, we can't appeal only to people who are happy doing their payments in crypto. We need to be appealing to folks who prefer to do their payments in fiat. We started the plumbing for that with the PayPal interface, but we're continuing and expanding that further. The publisher portal is the part of our infrastructure that lets you easily put AI services on the network and manage them and update them and monitor their payments and look at who's using them and so forth. I mean, the publisher portal does require some KYC or KYB to get your AI on there, because we have some legal liability for anything that we're listed. But if you are an organization or individual who's comfortable doing that, then you can make use of the listing service on our website, and you can more easily monitor various aspects of your AI via the SingularityNET marketplace. So there's a bunch of more crypto aspects here that I'm gonna not give that much time to, because I want to move on to the AI part. But I mean, there's staking we've introduced fairly recently, which staking lets you stake tokens on particular. It lets you. There's going to be many forms, but I mean the current form of staking lets you just stake tokens generically. Then you get some rewards if they're staked for a while. A more advanced form that we're working on now in the lab and haven't rolled out yet lets you stake your tokens on a particular AI agent, where you get more reward if that AI agent gets rated well, which turns the staking system into a kind of curation market. But even in its current simple form of staking, I mean, what this does is the staked tokens create a liquidity pool on the back end, and that liquidity pool of staked tokens can be used for market making to support the fiat to crypto and crypto to fiat interfaces. So this is all a lot of complexity that wouldn't be there in a centralized system just dealing with fiat currency. But I mean, it's there, it works, it's quite interesting, and it lets us handle, an AI marketplace with payment in any crypto token or in variety of fiat currencies, yet with this underlying decentralized infrastructure. So now I want to talk a bit about what I've spent most of the 30 years of my career on before 2017, when I co-founded SingularityNET and got into the crypto space. I want to spend a few minutes talking about artificial intelligence and the path from where we are now toward artificial general intelligence. And then I'll get in the final 10 minutes or so of the talk, I'll get to the intersection to how functional programming can help us take the next steps with SingularityNET, so that SingularityNET can, foster and benefit from advanced artificial intelligence and artificial general intelligence in a maximal way. So I introduced the concept of AGI, artificial general intelligence, in, I guess, 2004 or something. Back then, when I published the first book called Artificial General Intelligence and organized the first global artificial general intelligence research conference in 2006. Back then, it was a very obscure topic. Now you have Google DeepMind, OpenAI, you have these billion-dollar big tech sub-enterprises focusing exactly on building artificial general intelligence. But we haven't gotten there yet, but we're closer than we were 15, 20 years ago, certainly. The AI that is dominating the world economy now is what I would call narrow AI. These are AIs that can each do one highly particular thing well, but they don't have a broad understanding of context. In a profound sense, they don't really understand what they're doing. They can just do some specific narrow things. And we're in the midst of transitioning from that toward artificial general intelligence, AI that can generalize, transfer knowledge, abstractly reason in a way more like how people do, and ultimately in a super intelligent way beyond what people do. Certainly, just like humans are not the fastest creatures or the strongest creatures, we're not the smartest possible creatures. And there's little doubt our AGIs will vastly supersede us at some point. I think the path from narrow AI to AGI is going to pass through what I somewhat oxymoronically refer to as narrow AGI, by which I mean, systems that manifest some of the universal properties of AGI, but focus on particular vertical areas. So, if you look at what a mind does generally, a generally intelligent mind, it uses perception and memory to predict which of its actions will achieve which goals. Of course, there's more to the story. There's ambient self-organizing activity in any intelligent system, but this is a lot of it. And, this isn't really what GPT-2 or one of Tesla's self-driving car systems does, because these are narrow AI systems that are more like tools or libraries in the service of a fixed, unintelligent product architecture. But if you have systems that follow this basic methodology of general cognition in a way that's focused, say, on elder care robotics or on medical discovery or on driving a car, you have what I would then call a narrow AGI system, which I think is what we're going to see unfolding more and more in the next few years as we transition further toward artificial general intelligence. And my own research toward AGI has been focused on the OpenCog platform, and we now have a number of agents running on SingularityNET platform, where the AI code inside that Docker container on SingularityNET, that AI code is wrapping up an OpenCog runtime. So we have, for example, OpenCog AI agents analyzing genomic and proteomic data and looking at what genomic patterns in a person predispose them to a certain disease or predispose them to a certain drug being effective in curing them if they should get that disease and so forth. So we have some cool OpenCog AI agents running on SingularityNET already, but we're just getting started. And OpenCog does use neural nets, but it uses neural nets together with a whole bunch of other AI tools, so that the basic idea in OpenCog is you have this knowledge graph, which is a weighted labeled hypergraph knowledge store with this fairly complex combination of type systems on that weighted labeled hypergraph. And you then have a variety of different AI algorithms combining synergetically and coherently to choose actions that will achieve goals using the knowledge in that hypergraph. So you have neural nets for recognizing patterns in perceptual data and guiding low-level actions and allocating attention. You have a probabilistic logic engine for forming logical abstractions and drawing long chains of inferences. You have evolutionary learning algorithm for learning new programs and conceiving new structures and ideas. And these all interoperate together, reading from and updating the same knowledge graph. And this can be represented in a bunch of different OpenCog AI agents living in the underlying SingularityNET infrastructure and interoperating with each other. We've been working on OpenCog for quite some time. OpenCog as an open source project was founded in 2008, I guess, but the oldest code we wrote was 2001 or 2. We've now we're in the midst of architecting what we think of as OpenCog 2.0. So we're rebuilding a whole bunch of the system with a view toward greater scalability. And we have a spin-off of SingularityNET Foundation, like a separate company, but leveraging a bunch of the SingularityNET team and SingularityNET IP called True AGI. And True AGI, we're working on scaling up OpenCog and transitioning it toward an OpenCog 2.0 with a view toward using massive both server farm and decentralized infrastructure, having an easier to use AI programming language, which we call Adamese, and more scalable and easy integration between OpenCog and standard deep neural net frameworks like a TensorFlow or PyTorch. I mean, there's a lot of depth about the OpenCog 2.0 initiative that I'm not going to be able to go over here. But if anyone's interested in that, keep an eye on SingularityNet blog. Actually, about 2 weeks ago, we're having a whole 2-day event called OpenCogCon that just go on the online event that just goes into the nitty gritty details of how to build AGI using OpenCog 2.0 and what we've done so far with OpenCog 1.0. There's heavy aspects of probabilistic logic and programming here using probability theory, both to guide theorem proving, which has some relevance to smart contracts, the SingularityNet infrastructure that I'll talk about in a minute, and also automated program learning. I mean, there's quite new and obscure AI techniques. There's also some things we've used in a practical context. So with OpenCog running on SingularityNet platform, we've already done some cool things. We worked with Cisco using deep neural nets on street scene cameras and OpenCog logical inference to integrate the patterns extracted from the deep neural nets viewing things through the street scene cameras. We've used this, which is embedded in SingularityNet, to help Cisco systems better identify the high-level patterns in street scenes. And we're working also far beyond this. I mean, we're looking at some pretty cutting-edge computational chemistry, algorithmic chemistry approaches to computational creativity and to having the AI discover fundamentally new patterns. And in the practical application domain, we're working on whatever is valuable to our customers. So with Cisco, with street scenes, we're working with some folks doing COVID-19 clinical trials, using our AI to do precision medicine and figure out which combination of antivirals would be most effective for which patient based on their genomics data. For our more abstract AGI R&D with algorithmic chemistry-based learning and so forth, we're working with simple agents collaborating to build stuff in Minecraft-based worlds, and we're working with Hanson Robotics. So we've done a lot of work with the Sophia robot and Philip K. Dick robot and other Hanson robots before, and we're talking now to Hanson Robotics in the early stages of maybe starting a new collaboration of nursing assistant robots that can help out in hospitals. So there's a lot there on the AI side, which is much more than could be covered in part of a talk. And I gave a 4-hour epic monster interview with Lex Friedman, the premier AI podcaster, just a couple weeks ago. So you can look that one up on Lex Friedman's site. But what I want to do now for the last bit of this talk, before I perhaps answer a few questions from participants in the event, I want to talk about some of the future development directions. And we have some near-term development directions, like completing the fiat to crypto gateway and adding more types of smart contracts for different sorts of subscriptions. And we have a development kit for Android, but not for iOS yet. So there's a whole bunch of near-term development pathways, and we're updating the roadmap on the SingularityNet website within the next couple of days. On the other hand, what I want to talk about now is some of the further term stuff, like what do I want SingularityNet as a platform to be able to do 5 years from now, and or even 10 years from now. But let's think about 5 years. And this has a lot to do with AGI. It also has a lot to do with functional programming and many of the concepts underlying Cardano, which is why I decided to talk about this here. So, I mean, one possibility, I won't harp on too long because it's actually a pretty easy concept. I mean, we've built SingularityNET on Ethereum for convenience's sake. Solidity has many shortcomings, but it was pretty tractable to work with, and Ethereum was the biggest and most successful thing out there that had easily scriptable smart contracts. On the other hand, we don't control Ethereum development. I love what's being talked about with Ethereum 2.0, but it doesn't remotely meet our needs at this point, right? So, I mean, we've been looking at other options to cover the case that Ethereum doesn't end up doing what we want fast enough. We've looked at Algorand. I've been talking to the guys at Toda Network about building something custom using Toda just for SingularityNET, but Cardano is a project I've always loved because I started programming in Haskell, I think in 1993 when it was called Gopher, like before the GHC, before there were monads, right? So I mean, I've always had a soft spot for Haskell and then Agda and other functional languages generally. So Cardano certainly has been on my mind a bunch, thinking about the future of SingularityNET. And I've also thought a bunch about making SingularityNET multi-chain. So, I mean, there'd be nothing too hard about that in the infrastructure to allow different agents potentially to use different tokens and have some conversion in between. So we're certainly, we do almost everything off-chain, and the use of the blockchain is in certain parts of the daemon object. I mean, it's the decentralized aspect of Ethereum is critical to the whole dynamics and architecture, but that specific blockchain in itself sort of doesn't matter. So that's one aspect which can be interesting to talk about more. Now, multi-party computation. Multi-party computation is another interesting thing that we've played around a bunch with. I mean, so far it's very slow, which limits the practical applicability. We've gotten it to work sort of acceptably on specific cases in computation on genomic data in conjunction with some of our partners. But I think this is gonna, I know Cardano uses special cases of MPC deep inside the protocol, and I think MPC for machine learning is going to become tractable over the next years. And I mean, we can then interoperate MPC computation nodes with the daemon inside SingularityNet, and this should be quite interesting. So I mean, it'd have to get a little deeper into the AI agents that we're doing now, right? Like right now, basically any software program that interacts by a well-defined API, it can use the platform as long as it's integrated into a Docker container when the APIs are entered into the daemon appropriately. And that will continue to be the case. On the other hand, what we could have is a situation where if your AI agent makes certain types of API calls in the course of its operation, right, then these could be channeled through the MPC computation server. So if you're doing certain types of neural net learning, we may have MPC efficiently worked out for that type of neural net learning or decision tree learning or something like that. So if you go a little deeper into what's happening inside the AI, you may be able to let AIs that obey certain AI algorithms that you have efficient multi-party computing for, that depend on, say, matrix operations you have efficient multi-party computing for. You may be able to allow these algorithms to effectively do secure multi-party computation sort of enmeshed and embedded in the SingularityNET platform. And when you get there, the value of a functional programming-based infrastructure becomes stronger. So I mean, if you compare, for example, two existing platforms for multi-party computation and machine learning, ShareMind and ShareMonad, the ShareMonad being Haskell-based, I mean, what you can see is ShareMind, they had to build up like their own version of C, their own compiler, their own VM interpreter, do their own theorem proving, and almost all that came for free in ShareMonad due to the use of Haskell. I mean, they're all still too slow for many of the things we would want to do, but it's pretty clear that if you want to go in the direction of baking multi-party computation for machine learning and reasoning more into the infrastructure as a service that any SingularityNET developer could avail themselves of, I mean, then having a functional programming infrastructure is going to be highly valuable and just make the development of that MPC capability in the platform a lot simpler. Something else cool that goes back to my days doing computer science research. I mean, you'd like to have someone put fairly simple AI code running on one machine or one processor into SingularityNET, and then have some funky code associated with SingularityNET just rewrite that code to make it run efficiently across many different processors. And ultimately, you're going to need something like this in order for decentralized AI platforms to really compete with Google and Amazon, because Google and Amazon have really funky ways to massively parallelize AI code written using their internal APIs. But again, you can do this using functional programming in principle, right? I mean, there's already projects out there that take recursive functions in Haskell and they sort of unroll them and rewrite them when they can into extremely parallelizable functions in Haskell. And the example I'm flashing on the screen here, it's trivial, but you take recursive implementation of factorial function, and this code will automatically rewrite it into a parallel version that can be then done in parallel on many different processors. So, I mean, this example is very simple. More complex examples also work. Ultimately, what you need is someone can upload their AI into a container, maybe on some managed hosting associated with SingularityNET, and then there's a code optimizer that can dig in and rewrite that code to make it run effectively across many different machines, but still accessible in the same way through the APIs accessible through SingularityNET. Now, we're not there yet, but you notice a common feature with the MPC stuff I talked about. Like this also would require the platform to look a little deeper into the AI code than what we're doing right now. And when you get there, where you're offering like special optimizations or security features to AI code that's written in a certain way, leveraging certain library functions, then is where you start to worry, well, what language is the AI code written in? And that's where having a common functional language framework across some of the AI code and the platform code becomes valuable. Something else really dear to my heart is we think of as swarm AI. Like right now, we can take an OpenCog system and put it in a SingularityNET agent. We can take a number of them and they can cooperate and get some synergetic intelligence across the platform. But I mean, in the end, there's a lot of intelligence in each of those agents. Like each agent might use a terabyte of RAM and have dozens of processors. An alternate approach will be more artificial life-ish, right? Where each agent may do a very small amount, and you have millions or billions of agents, and the intelligence is almost entirely on the cooperative level, rather than like with OpenCogs now, intelligence is largely in the agent, and then you have multiple agents synergizing to get a level of collective intelligence on top of that. But current blockchains are just insanely too slow for this sort of swarm-based intelligence to exist. When we move to a more efficient blockchain, or when Ethereum becomes massively more efficient, that will open up really interesting new frontiers on the artificial life and society of minds level. Now, getting the recursion even a little deeper, one of the areas of AI I'm personally most interested in, as my PhD was originally in math, one of the things I'm personally most intrigued by is automated theorem proving. And my oldest son, Zarathustra, is doing his PhD now on automated theorem proving. And, one of the big applications of automated theorem proving is in, checking the formal correctness of software programs, which is very important in computer security. So this could be an area where you have a very interesting virtuous cycle where, open cog systems doing a combination of crisp theorem proving and probabilistic reasoning can learn new smart contracts and check the correctness of smart contracts on the platform. On the other hand, the platform is then hosting these open cog theorem proving agents and enabling them to have more and more distributed intelligence through being an effective platform. And this is, if you've never seen the novel Accelerando by Charlie Stross, which foresaw smart contracts like well before Bitcoin, let alone Ethereum. I mean, this is basically Accelerando, right? This is an intelligent network of companies that are constantly rewriting their bylaws as well as optimizing their own digital money-making operations, turning into a whole intelligent meta corporate system of automated companies. I mean, it's science fiction, but we could get there with the next versions of OpenCog / True AGI, the next version of SingularityNET platform, and an appropriate, functional programming based infrastructure underlying SingularityNET platform. And that's you can also pull in there complex simulations of the network, and we have a simulation model of SingularityNET right now. And again, on a functional programming level, if you have a simulation of a network and then you have the real network, right now we compare the simulation and the real network sort of by hand by our own scripts. If you're doing it all in a functional programming universe, you can have a simulation of the network, the real network. You can categorically, theoretically define a morphism between the real network and the simulated network, and you can go back and forth between reality and simulation in a very, very elegant way using morphisms and functors. So I think a lot of these advanced capabilities that we need to implement the overall decentralized network of decentralized networks that I think can lead to emergent AGI and a benevolent global brain with democratic decentralized control and all this good stuff. Part of the story is using functional programming to help make it smoother to bring advanced AI and decentralized blockchain-based networks together, among other ways, in some of the ways I've outlined here in the last 15 minutes in the talk. So, well, I had to talk pretty fast to get through all that in like 55 minutes, but hopefully it was at least partially comprehensible. I think I've left like 6 minutes or something to answer questions, perhaps. So let me look at some of the submitted questions that have come through. How do you have a unified SingularityNET ledger while on different blockchains? I mean, the SingularityNET doesn't require a unified SingularityNET ledger. I mean, you could have a SingularityNET with multiple blockchains with multiple ledgers. I mean, you can even, with Toda, for example, you could build a ledgerless blockchain. You don't necessarily need a ledger behind the blockchain. In Toda, what happens is each file that you send across has its own history in it, which could enter into various rings that do various sorts of consensus, and you don't need a ledger. So, I mean, we really built SingularityNET to be insulated from these lower level details. So, another question, in a sense, general AIs are just doing a specific task. While many AIs are doing different things, they're not doing different things together. Well, I don't fully understand that question, but it's true that a fully general AI, in the sense of Marcus Hutter's Theory of Universal AI from his 2005 book by that name, a truly general AI that could optimize any computable reward function in any computable environment is something achievable only with infinite computation power. So it's not even physically possible. On the other hand, I think there are pretty clear senses in which a human being is much more general in AI than a worm, a dog, or any current software program. And we spend a lot more of our resources on generalizing knowledge from one domain to qualitatively different domains. And in the developmental psychology sense of Piaget, I mean, we are we are at the formal stage. I mean, we're capable of abstract quantifier manipulations and Turing complete simulations in our mind, whereas a dog or a worm or a narrow AI program isn't. So I think there is some sense of formal generalization you can characterize mathematically that isn't absolutely general intelligence, but is different than what narrow AIs are doing. And it's an interesting question whether you could take a whole bunch of narrow AIs and just how they combined together yields general AI in the totality. I mean, there's an argument that's what the human body is, and each neuron and glial cell is doing a bit of adaptation. So they're very narrow AIs, and they come together to yield the brain, which has much more general intelligence. Now, like I said, what we're doing with SingularityNET now, the most intelligence is in the individual agent, like an OpenCog system. And then you're getting an added layer of emergent intelligence, in some cases through their coordination. The swarm AI approach will be each intelligent node is pretty simple and maybe doing some quite simple pattern recognition or reinforcement learning. And you try to get the whole collection of AIs to have some emergent intelligence. You can't do that on chain now. It's just too slow and too expensive. I think I want to build a blockchain-based decentralized AI framework that can be used in that way, and then let the OpenCogs communicate with the swarm AIs and see what emerges. I mean, I think OpenCog has potential to yield human-level AGI. I also think there's going to be many different routes to create many different kinds of human-level AGI, just as there are many different ways to build flying machines, all consistent with the laws of aerodynamics. Someone has asked if SingularityNET offers AI for agricultural use. I mean, at the moment, there are no AI services running on SingularityNET focused on agriculture, but I mean, there's maybe 50 AI agents on the network now. It's not scaled up to the level that we hope it will be, say, a year from now. We're still in relatively early stages. I have previously done work using computer vision and machine learning to, for example, identify crop disease from images of either whole fields or of individual plant leaves. So I know from experience there's great applications of AI in this domain, and I would love to see some developers jump on and leverage SingularityNET in that way. Someone asked, any thoughts about Bayesian nets, or do you only use neural nets? Well, actually, we don't. I mean, SingularityNET, you could put any AI you want, and I hope all people around the world will put cool different AIs in there, and we can see how they can compete and cooperate. In our own work, we use deep neural nets quite extensively for voice processing, vision processing, video, audio, and so forth. For abstraction and reasoning in our own AI projects, in OpenCog and TrueAGI, we tend to rely more on probabilistic logical inference or probabilistic programming, so more symbolic methods for abstract reasoning, and then we connect them with neural nets for sensory data processing, which you would refer to as neural symbolic AI. And that's what we're doing in our own AI research, which is embodied in some of the AI agents on SingularityNET. But SingularityNET as a platform is and should always remain, I mean, completely agnostic to what AI algorithm you're putting in there. I mean, we want that to be diverse as well as decentralized, and let it be like a sort of digital evolution where the best AIs prevail because they can make more money and accumulate more resources by providing better services. And part of being the best may be cooperating with other AIs in an optimal way. I'm pretty much out of time, but let me answer one more brief question. What role do humans play in the world of AGI? Well, right now we play the role of creating the AGI and building the blockchain-based infrastructure for the AGI, which is a hell of a lot of fun. But I mean, the goal obviously is to create AGIs that not only can go off and do their own amazing AGI things, but that also can help create, a universe of ongoing health and abundance for human beings. I mean, that's what we're after, is beneficial AGI to make human life astoundingly better than it is now, as well as to create amazing new digital life forms. And I think it's quite possible, if we make the first AGIs on the planet beneficial and loving and compassionate and helpful rather than malevolent killers or advertising agents or spies or whatever, I mean, that requires us to use AGIs for good things like teaching and counseling and medical and research. It also requires that the AI be deployed in a decentralized and democratic way so that nefarious centralized forces can't take it over. I think there's more interesting questions, but it's now 4:31. I'm over time. I should probably stop now. So thanks everyone for all your cool questions, and thanks everyone for listening. Thanks to Charles Hoskinson and Cardano for inviting me to speak here. I love Cardano project, so it's been quite an honor.